Now, this is the another example, and I'm not gonna go through the example, the same thing as we did before. So please do not like do these steps. So we don't need these two. Okay. So start over from here. The same thing. We start with the sodium with the NaCl, okay, and chlorine with the NaCl. The same thing. You do the same thing as the previous one, and you got everything right here. So we first of all we calculate the moles of the NaCl, and from the NaCl by the comparison between Cl2 and NaCl, and after that we can determine which one is the limiting reagent. All right. Now, calculation of gas volume. So for the gas volume, it's the same concept as we did with the mass, except that there is like a slightly difference between them. So now, if we want to calculate the normality of any substance, we say the number of mole. The number of mole equals the mass per gram over the mole mass of any substance, right? This is the first step. The second one, we have like some laws that we need to pay attention to. First of all, the normality equals PV over RT. Okay? PV, P means the pressure, V the volume, R the gas constant, which is 0.038 and or 83, sorry, and the T is the temperature. It could be in Celsius or in Kelvin. Okay, the normality equals V at STP over 22.4. This is another law. Okay, this is the first one. And if we want to calculate the mass, we say like so the number of moles times the mole mass. Okay, and if you want to calculate the V, so we say number of mole times R times T over the P, the pressure, and the same thing with the V. So all these three are derivatives from the first one and the second one. So these are the main laws that you will need to memorize, and then if like one of them missing, then you can calculate the rest. Okay, so let's take this example. According to the following equation, nitrogen monoxide gas changes into brownish nitrogen dioxide gas through the reaction with oxygen. So we have 2NO, like 2NO plus oxygen gives us 2NO2 as a gas. Calculate the volume of formed of NO2 from the reaction of 34 liters. So we have the volume right here of oxygen with enough of NO. So the volume of O2 is 34 liter, and the volume of the NO2 is missing. Okay, this is missing. Now, do you remember with the previous example? So when we wanted to calculate the number of moles of any substance based on the number of moles of another substance in the limiting reagent, this is the same thing, exactly the same thing. So we take the volume per liter equals 34 per liter of oxygen times, so the product is NO2 over O2. So how many liters? So we have 2 liter, okay, and we have 1 liter of oxygen. We get the how many liters of NO2, which is 68 liter. Okay, this is it. Okay, it's a symbol. Okay, now let's take another example. Calculate the volume of obtained O2 from heating of 3.5 moles of KNO3 according to the following equation under the standard conditions STB, which means that the temperature is 25 Celsius and the pressure is 1 atmosphere. So we have this equation 2KNO3, which is a salt. That's resulted by the action of KOH, potassium hydroxide with NO, which NO3, HNO3, which is the nitric acid, gives us KNO3. So the KNO3, like when we heat it up, it will dissociate to give us KNO2 plus O2. It releases oxygen. Okay. Now, what we want to do here is to calculate the volume of obtained O2 from like 3.5 moles of KNO3. So we have the number of moles of what? Of KNO3, this one. And we want to calculate the volume of O2. So number of moles of any substance. So from this one, we can calculate the number of moles of the oxygen. So now we have the number of moles of KNO3, and we cannot calculate the volume of O2 based on the number of moles of KNO3. So first of all, we want to convert the number of moles of KNO3 into the number of moles of oxygen. So we do this conversion by doing this little or short law, or using the law right here, and which is the number of moles of any substance, okay, which is 3.5, the known one, times the number of moles of the missing, which is 1 mole of oxygen, over the number of moles of the known, which is the KNO3, which is 2 in the equation. So we have 2 moles right here, gives us 1.75 number of moles of oxygen. So we have the number of moles of oxygen right now. From the number of moles of oxygen, we can calculate the volume of oxygen. So the volume of oxygen, as we mentioned in the previous slides, when we say this is we have 2 laws that you need to memorize. This is one of them. The volume of any substance gives us the number of moles of that substance, the same thing with oxygen, times 22.4. This is constant value over 1 mole, okay. And then we just apply the numbers that we got, 1.75, which is from here, times 22.4, it gives us 39.2 liter. So it's kind of manipulating with numbers. This is all we have for today. I want you to do these 5 exercises, okay, and send it to me by after tomorrow. All right, okay, see you then.